This is one of the quick videos on explaining a little bit in more detail topics in chemistry, physics and biology. This particular topic is the last lesson from topic 6. So this is lesson 7, reversible reactions. So we're going to be exploring a little bit more on what is affecting the reversible reaction and dynamic equilibriums. Okay, so these you already studied some of these. Okay, so you should know, you should have been familiar by now with this symbol. This is a symbol of a reversible reaction. Okay, you should know that reversible reactions must happen in a closed system in order to have something called dynamic equilibrium. Okay, and if that's a closed system, there will be no overall change in the amount of products and reactants, okay, even though the reactions are ongoing. So there will be no addition of matter or matter escaping. It's just going to be only energy transfer in the process. Okay, there's a link in that video that you can follow. I'm just going to explain a few of the main conditions that affect dynamic equilibrium. Okay, this is called Le Chatelier's principle, and it has to do with the position of the equilibrium in a reversible reaction. So normally the reaction can be shifted from one direction to the other, left or right, depending on what we change on that reaction. So mainly things that we've seen so far will be temperature, concentration, pressure for gases, and catalyst. So catalyst, you already know, speeds up your reaction, but in this case it has no effect on the position of the equilibrium. Okay, so if you're not sure about what an equilibrium, dynamic equilibrium is, we'll just try to discuss about it, and hopefully we'll clarify a little bit more. You can also search further on YouTube by just typing dynamic equilibrium. You can find some really nice videos on few schools or free science GCSEs. But I'll try to explain it a bit more here with some slides that are a little bit more wordy for people who like to read a bit more information on it. Okay, so we're going to look at temperature. So the equilibrium is in the middle. Let's start with the middle. So the dynamic equilibrium is in the middle, and here we have a process called the diamerization of nitrogen dioxide into dinitrogen tetroxide. Okay, nitrogen dioxide is a brown gas, and as it becomes dinitrogen tetroxide, it's a clear gas. So we can see from some color changes the movement of the equilibrium. What you need to remember for temperature changes is this. So we can read this one, for instance. The forward reaction is an exothermic and the backward reaction is endothermic. So what we saw earlier, okay, was this definition here. If the temperature is increased, the equilibrium shifts to decrease the temperature, and the equilibrium shifts to the endothermic direction. If the temperature is decreased, the equilibrium shifts to increase the temperature, so the equilibrium shifts in the exothermic direction. If we put it in a more simple kind of like way of understanding this, so the equilibrium is in the middle. So if you were to increase the temperature in this reaction, okay, your equilibrium is going to start moving to the left, okay, and you'll see more reactants being produced. Okay, if you increase the temperature, So the equilibrium, as you can see, if you increase the temperature, the equilibrium shifts in the endothermic direction. It's the direction where the energy is being absorbed. Okay, so if you decrease the temperature, so you're in the equilibrium again, if you decrease the temperature in this reaction, you see the equilibrium is going to move to the right, which is the exothermic direction, and you will see the equilibrium will move to the side and it's trying to produce more products. Okay, so if you increase the temperature, the equilibrium will produce more reactants to balance out the excess temperature rise. And if you decrease the temperature, the equilibrium is going to move to the right, putting more energy in to balance out by producing more products. So I hope that makes some sense. Now, how is this visible? So when you increase the temperature and you move to the left, you see that your mixture is going to start turning more brown, darker brown. And if you decrease the temperature and you move to the right, the mixture is going to start being paler. So hopefully that makes sense on how temperature affects the equilibrium.